Hi everyone, welcome back to our channel. So Somu sir, what are we discussing today?
Discussing actually a very simple problem, Harshal. I mean,
Okay.
on the face of it, this might look something related to time speed distance, because minimum possible time, and the question that we are looking for is related to that. But actually, it's a geometry question. The main context and most of the context is related to geometry. So let's first comprehend it. And by comprehension, I mean, most of it must be solved any which way. So we have a ABC, a right angle triangle with BC as the hypotenuse. Lengths of AB and AC are given to us. What is given, don't focus on that much. So AB and AC are given to us. Now we are looking for the minimum possible time in minutes required to reach the hypotenuse from A at a speed of 30 km per hour. So think about the question for a minute. What is the question? The objective here, we are looking for the minimum possible time to travel from A to the hypotenuse with a particular speed, right? So with a particular speed, if we are looking for the minimum possible time, so the obvious thing we have to travel is the minimum possible distance, isn't it?
Right.
Because the speed is fixed. So
Correct.
if we have to travel the minimum possible distance from A to the hypotenuse, so basically what we are looking for is the minimum distance of A to the hypotenuse. If we can figure that out, we can get the answer, isn't it?
Right.
Minimum distance of a point from any line is the perpendicular distance.
Correct.
Basically, we are looking for the length of the perpendicular drop from A to the hypotenuse. Now, those who have practiced right angle triangle type of question, this is a piece of cake problem. It's a very, very easy problem. It's a sitter. So let me just show this once. So A is the 90 degree. I'm not marking this as 90 degree. This is the 90 degree. And we are looking for the perpendicular distance from A to BC, right? So let me just draw that. So this is what we are looking for, right? Let me mark this as D or something. We have AB as 15 and AC as 20, right? Now, what is the area of ABC? Area of ABC is basically half into 15 into 20.
Correct.
Because if I consider 20 as a base, 15 is the height, right?
Right. Right.
Also, half into AD into BC, right? The area.
Correct.
Now, what is BC? Let's just quickly figure this out. This is 3 into 5. This is 4 into 5. So BC should be 5 into 5. 3,
Right.
4, 5 triplet.
3, 4, 5. Correct.
Use Pythagoras, root over 15 square plus 20 square, but this will be faster. So BC is 25, right? So this is also the area of the triangle ABC. This is also the area of the triangle ABC. So these two are equal, right? So this half goes off. So AD comes out to be 15 into 20 upon 25, which is, this 5 goes off here, 5 goes off here. So we have 3 into 4, that is 12, right? So AD is 12 kilometers. Everything is in kilometers, right? So if AD is 12 kilometers, that is the minimum distance you have to travel. The time required would be distance upon speed, but this is in hours, right? We are looking for in minutes. So convert that into 60 minutes. So this is twice of 12, or rather 24 minutes as our answer.
Right. Pretty simple.
Pretty simple. A sitter, right? These types would be qualified as sitters. And as I said earlier, although the question is looking for minutes with a speed,
right,
text is geometry, right? It's triangle and hypotenuse and stuff.
Even for a minute, I was also confused that we actually completed our time, speed, and distance, arithmetic series a while back, and again we are back with time, speed, and distance. But no, this was nice.
In the latter part of the time speed distance questions, we encountered some problems which had something to do with geometry. But if you remember, those questions, the primary thinking was time speed distance, right? There was some basics of geometry involved. But this is the other way around. The primary thing here is the geometry part, a little bit of time speed distance in terms of the objectives. So it just twisted the question in a way which looks like time speed distance. Not look like, we have to use the basic idea of this time is equal to distance by speed. That has to be used. But yeah, primarily it's a geometry problem because of the main idea out here. You have to determine the perpendicular drop from the A to the hypotenuse, something like that, right?
Right.
And this is, there are a lot of ways to actually figure this out, but this is always the simplest way of doing this.
Correct.
Perpendicular to the hypotenuse of a right angle triangle. This is the easiest way. If you know the three sides, just equate the area in two different ways.
Correct.
So yeah, that's it.
Thank you, sir. Thank you so much for this question. Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.